Okay, this is under complex numbers. Describe the locus of the complex number z, which satisfies the modulus of z. This is z, this is z, as you call it. Z minus 2 plus 4i equals to 3 modulus of z. You should know that since z is a complex number, we can rewrite z as plus iy. That is the definition of a complex number. Complex number has a root, which is the x, and the imaginary, which is the y. You all know that I is an imaginary number, square minus 1. So we have to put this back into this equation. You should read again this locus. We have to describe the locus. That's the shape at which the this equation will look like in a graph. That is the meaning of the locus we have to describe. So now put that x plus iy as z minus 2 plus 4i equals 3 plus x plus iy as your z. So now I want to group those with the x, and the ones with the real number I take it to one side. X minus 2 plus 4 plus y. Then I can bring out my I and then put my modulus back. I grouped this and factor out I, and I got 4 plus y, and bringing out my I out, and this is equal to 3 modulus x plus iy. So now to get rid of the modulus, sign, we are to square root the sum of the squares of the real part and the imaginary part. The real part and the imaginary part. We are not to use the I. This is the real part and this is the imaginary part. We are not to use the I when we want to get rid of the modulus sign. And this is equal to 3 the square root of x squared plus y squared. Now to get rid of the square root, I square both sides and I get x minus 2 unsquared plus 4 plus y squared equals to 9 in bracket x squared plus y squared. So now doing some algebra, expanding this, I have x squared minus 4x plus 4 plus 16 plus 8y plus y squared equals to 9x squared plus 9y squared. Taking like terms, I say this is 20 and this is equal to 9x squared minus x squared plus 9y squared minus y squared plus 4x minus 8y. I took this here and I got minus. I took this here and I got positive. I took this here and I got negative. I took this here and I got negative. So you should understand that. So from this I got 20 is equal to 8x squared plus 8y squared plus 4x minus 8y. I want to divide through by 4 and I go 5 is equal to 2x squared plus 2y squared plus x minus 2y. Okay, now I could stop here, but I haven't seen the locus of the graph, how the graph should look like. I haven't really seen how this can be in a graph. So I would love to continue by grouping those with the x. I have 2x squared plus x, and for the y, 2y squared minus 2y, and this is equal to 5. Don't forget. So I can actually say I want to find a perfect square for 2x squared plus x. I want to add a number to it that will make it a perfect square, and the same thing applies to the y. But before then, I would love to factor out the coefficients of x squared and the coefficients of y squared. So this is 2 in brackets x squared plus x over 2 plus 2 in bracket y squared minus y. Now I have factored out the coefficients of x squared and also the coefficients of y squared. Now to make this inside a perfect square and this one as well a perfect square, there's a reason for that. So let's go. Making this a perfect square, I would find the half of the coefficients of x and add it to it and square it as well. So doing that, I would say this is 2 in bracket x squared plus x over 2, half of 1 over 2, that is 1 over 4. 1 over 4 squared, that is plus 1 over 16. So this would make the inside a perfect square, and this is plus 2y squared. Now the half of minus 1, which is the coefficient of y here, the half of minus 1 is minus 1 over 2, right? So the square of minus 1 over 2, that is plus 1 over 4. So I would say this is minus y plus 1 over 4. Don't forget, since I added this to this side of the equation and as well added this to this side of the equation, I would as well do the same in this part of the equation so as to make the equation balance. So by doing that, I say this is y and 5 plus 5 plus, if this multiplies this, I would have 2 in brackets 1 over 16 plus this multiplies this 2 in bracket 1 over 4. So I have to add this to the right side of the equation because it is already at this part of the equation. So you should understand that so as to make the equation balanced. So from here now I know this is a perfect square. By solving this, I say this is 5 plus 1 over 8 plus 1 over 2, and this is equal to 2 in bracket. This is a perfect square and I can write that as x plus 1 over 4 all squared. If you should expand this, you would have this. Yes, if you should expand this, you would have this, and this is plus 2 in bracket y minus 1 over 2. Remember, when we find the coefficients of this, we go minus 1 over 2, and that is why it is minus 1 over 2 and not plus 1 over 2, and this is all squared. So now, looking at this, you're already getting closer to a circle. If you should notice, we are getting really closer to a circle because a circle, as you know, is a is x plus a all in bracket square plus y plus b all in bracket square equals to c square. That is the formula for a circle where a and b are the points at the x and the y axis respectively, and c is the radius of the circle. So now from here we can see that adding this up would have 8 at the denominator, and then this is 40 plus 1 plus 4, that is 45. That is 45 over 8, and this is equal to 2 in bracket Now, I can actually divide 2 by 2, and when I do so, factoring out 2, I would have x plus 1 over 4 all squared plus y minus 1 over 2 all squared. And then dividing 2 by 2, I have 45 over 16 equals to x plus 1 over 4 all squared plus y minus 1 over 2 all squared. Now I can tell you that because of this equation, of this complex equation, is actually a circle with the radius the square root of 45 over 16, and the x-axis 1 over 4, and the y-axis 1 over 2, where the radius is the square root of 45 over 16, because the square root of 45 over 16 raised to the power of 2 is 45 over 16. So now we can deduce that this has a locus, a circle as its locus. So thank you for watching.